Okay, so can you do a 1-minute intro and then we can get started?
Got it. I'm a SD with 8 years of experience, and I'm looking to crack companies like Google.
Cool.
Yeah, trying to get some practice.
Okay, so we're gonna do 45 minutes. So right now it is 3:07, so we'll go until 3:52. Okay. Pacific. So you manage your own time. We're gonna have 2 problems. Okay.
Got it.
Okay. So the first problem, you're given an array of digits, and it's ones and zeros.
Mm-hmm.
And basically, what I want to do, so like, let's say you're given this, I want you to perform operations to make this array monotonically increasing. So do you know what monotonically increasing means?
So it should be like 0, 0, and 1, 1, right? Continuously increasing.
Yes, that's correct. So any combination, so like all zeros would be increasing all ones, as long as
Once
you just can't have a zero after a one. And the
got it.
operation you can do
Mm-hmm.
is for a number, you can flip what it is. So if it's 0, you can make it a 1. If it's a 1, you can make it a 0. This costs 1 operation, and return min operations required to do this. So in this example, for example, you could just do flip the last one, and you'll get this. So this would be 1.
Got it.
Yeah, feel free to ask anything you want to.
Okay. So it's only 0 and 1s, and minimum number of operations to make it monotonically increasing. Got it. And the only operation I can do is I can flip 0 to 1 or 1 to 0, right?
Yes.
Got it. Let me try some example to see if I understand the problem correctly before I.
Sure.
Yeah. Okay. So if it is only 0, 0, 0, then it's monotonic increasing, so no need to do anything.
Mm-hmm.
Similarly, if it is 1, 1, 1, again it's a monotonic increasing, no need to do anything.
Mm-hmm.
If it is in the reverse, then I need to I need to, in this case I need to probably make it if it is equal, since I can actually make it 0, 0, 0, it will be monotonically increasing, or I can actually make it 1, 1, 1, 1, 1, 1. So that also monotonic. So operation is 3 operations I need to make. Okay. The now when the at every, let me go with some more complicated example before I come up with any solution. So in such example, I need to what are my options? I can make it at every point. Okay, how many zeros are here? At this point, there's 0, 0. At this point, there is 1 equal. Here, it's almost, let's say then here it's also equal. So I have 2 operations. Here, I have 3 zeros. I have 2 ones. So if I have to make it, I need to make that. Yeah. So let me walk through this example more. So what I will do is, so here, if I'm going from back, I will make this last as a 1, because after the 3 ones is coming, and I cannot flip entire thing. And here I have two choices whether to make it 0 or 1. It's better to make it 0, because there are
I think in this case it wouldn't matter. Like you can make it all zeros or ones, and it would be the same cost for those 4.
First 4, is it? Oh, okay.
Not first 4, but these 4.
These
Like
4.
if you make them all 0 or 1, it's the same cost because it's 50-50.
Oh, okay, got it. Oh, okay. That is the uh, what at every point, if there's more zeros, uh, uh, at every point I can. Okay, let's let the brute force is. I can think about. Uh, I can have an two loop, and in the one loop, I can count. Wait, can I at every j how much whether I can make it zero here? Okay, so at the brute force is at every in I can actually check um, um, how many zeros, how many ones before, and how many uh, zeros after, and that will be my um, that could provide me that and that could provide me the my value. So at every operations, how many are zero after and how many are one before, right? Will what it will give me. So for example, let's take this zero. If I check, there are two ones before, I need to make this is into two operations, and here I have one operation, and this intersection, this can be like zero or one, doesn't matter. So they have two, and in this case I have like three operations to make this into an valid uh, uh, valid monotonic increasing string. What do you think about this brute force approach? Uh,
Okay, so basically you're saying at every operation you're gonna see, like, let's say you're here, you're gonna say how many before this
how many
are
before? Yeah, one, and
uh-huh.
how many after the and maybe like how many after them are like zero.
Because you need to change the ones before that are one into zero and the ones that are after that are zero into one.
Yes, yeah.
Yes, so this makes sense. So what would be the time complexity there?
So if I'm like if I'm using an like a kind of a prefix sum, I can even do this in if I have a I can even do this in order of n. Otherwise, I have to like loop through the entire thing again and to find maybe order of n square.
Yeah, so I agree. So I think with the prefix sum we can do this in order n. So then
Hmm.
what, so your solution would be order n.
Yeah.
Okay, I think this makes sense.
Hmm.
Now, mm, okay, so right now we need a prefix sum, I guess. Yeah, so let
Yeah.
me ask you.
Order.
So we need a prefix sum of like ones and zeros, right? Is there
Right.
any way we can do it where we have an O of one space solution?
Okay. Let me. Yeah. Let me think about that. Uh, so what is my problem here? So I want. So let's say if I maybe I can think about something like a sliding window or something, maybe where I don't need the prefix sum. In this case, if that is the case, uh, if it is equal, what is my shrinking and what is my expand operations? Is it what is my shrinking and what my expand operations? Uh, I'm oh you yeah, it will be easier if it is a prefix sum, but okay, if without that.
So
Mm,
basically you said you need to
oh,
know how many ones
actually, I
before
can.
and zeros after, right?
Yeah, I can first time I can do do the calculation and I can count what how many zeros and how many ones, and
Mm-hmm.
with that I can actually see if how many ones I have seen,
Mm-hmm.
uh, and using doing some math. For example, this in this totally there are what uh, five ones,
And four zeros.
four zeros. Uh, so at every point I can actually count how many zeros I have seen,
Mm-hmm.
how many ones I have seen. For example, I have seen here two ones, two ones. It means there should be three ones, and my n is how much? 1, 2, 3, 4, 5, 6, 7, 8, 9. N is 9. So I have seen my currently I'm at 0. Wait, uh, 0, 1. Let me, 1, 2, 3, 4. 5, 6, 7, 8. Correct, right?
Oh, like the index and stuff?
Yeah,
Yeah, I
index.
think,
Yeah,
yeah.
because I want to know what index I am at, so that
That's right. Yeah.
yeah. I'm sorry, I'm here. Okay, I'm at fourth index. Let's say fourth index.
Mhm.
So there will be like and n is 9. So n minus 1 minus current index gives me I have 8 minus 4. I have 4 more elements.
Mhm.
In that um, I have seen already 2 zeros. I have seen 2 zeros, and I have seen 2 zeros, 2 ones. So remaining should be 2 more zeros, if excluding the including the current one,
Mhm.
and 3 more ones. So I know that these 2 ones I need to switch, and and then here should I what there's a maybe if I exclude the current one, then actually like one more zero on the other side. So I can keep it in the variable, and I can uh, with the zero space I can do this, right?
Mhm.
And I can actually calculate this for every element, and the max the so we want again sorry we want the min operation, and what is the min will be the uh, yeah I can do the minimum with this.
Okay. Yeah, it makes sense. I think
Mhm.
I'm getting what you're doing. You can write down any other notes if you need to, or you can start coding. Up to you.
Oh, okay. Let me actually before I write, let me like formulate my idea.
Sure.
So first I need to like calculate the how many ones total ones and uh, total ones and zeros uh, at every index. I need to calculate um, how many I need to like calculate how many ones I have seen. And actually, I would better calculate the zeros also. I don't need it. I can actually use the index minus the ones will give me the zeros.
Okay.
But I'll just have it because for the simplicity. So I can calculate how many zeros I have seen, um, including should I include this one or not? Maybe I'll. That is my question. Should I include this current one or not? Let me take another case to see if I have to include the current element or not. uh, let's say 0 and 1 is there, like 1 and 0 is there, and at I at 0 uh, and I am seeing um, I need to I have seen 1, so I know that there is one more 0 left, and I have to like change I have to switch that. Wait, that is little become a little more complex. So but my approach is how many uh, ones before. So here how many ones is at how many ones is 0, how many zeros after. um, so it okay zeros after. This is strictly not including, and this is how many zeros after including. Correct. Yeah. So there will be like 0 1, and I can actually do the one operation. Well, this takes care of all the edge cases. Let's see if there is only one is there. uh, hmm. I, okay. Not. Let me apply this algorithm on your examples which you gave me.
Sure.
Uh, so here the example, right? Uh, at 0, uh, at 0th index, how many ones before, how many 0 including after.
Mhm.
So how many ones before? 0. Totally 0 equal to 3, 1 equal to 2. How many ones before, which is 0? So I know 2 ones are after, but it doesn't matter. For how many zeros after? 3. So at this syntax, if I'm doing it, I'm making this as a one. I need to like have a, if I'm making all others 1, then I need 3 minus 2. So 3 minus 1, I think 2 operations. Intersection doesn't matter, but I don't know why I'm calculating that. I'm like facing before I write. I know there's an edge case there. I'm not properly understanding that. This is the reason I'm like walking through an example.
Makes sense.
Yeah. At 1, so we have 1 is 0. 1 is 0, and 2 zeros after. So 2 zeros after. So it will be like again 1 operation. Again at here. Wait, I got my answer already. Yeah. At 1, actually, if I'm, let's say, 2 syntax, if I'm doing how many ones before, like 0. Second, that is 1 operation. Yes. Wait, 1 0. 1 0. I think I should not include the current number to anything. Yeah, that is because instead of minus doing minus, so 1 0 is after, so I'll do that. So I'll not include the current number to anything, and I think that will solve the problem. I can code. I feel.
Okay.
What do you think?
So let me just ask you one quick question. So let's say we're on this number.
Sure.
Can you explain why you are not including this number in anything?
Because at this number it can be like 0 also, and it can be 1 also, and it's a valid thing. This is the middle, and it's a valid, right? So for 0 0 1 1 1 also valid, 0 0 0 1 1 also valid, right?
Yes. Yeah, that's right. Okay. Just wanted to make sure you got it. Okay. Yep. Okay, you can go.
Got it. Yeah. Oh, thank you. Okay. Let me. So what is the? So I'll be given an array, right? And I need to return a int, right?
Yes.
Can I clean this up or like?
Yeah, you can get rid of all the stuff you don't need.
Oh, okay. Sure. Yeah.
And because you don't write your code, you can just write a function without a main or something. You don't need to like call it. It's fine.
Sure. Okay. Public. So this is will be int, and what is the operation you want? What is the
Whatever
operation?
you want it to be called. I don't care.
It's called monotonically increasing min operation. I'll let me shorter. Okay. And let's say the limit is array. First thing I need to do is tab is little one count and 0 count, total 0 count and 1 count. Zero is 0 count, else it will be 1 count. Now I'm done with that. Now I need to return my min op. Let me name it as. So this can actually fall in the int, right? There won't be like
yeah, you won't have any overflow. Yeah.
Overflow. Okay, got it. So I need I should name it as total so that confuse it with one count so far and 0 count so far. So what is the current number operations required at this right? The current the operation required is how many ones before and how many ones before, and I need to know how many zeros after. So I know there are like n minus 1 and wait, what is that? I need how many? Wait, I can just do the minus here. How many zeros? I have how many zeros I have seen so far. There are 2 zeros. I have seen 3. Would this work? Yeah, let me do the will it work? 3 zeros at this point. Yeah, 3 zeros. I haven't seen. Yeah, I haven't seen anything. So it will be 3 0. I've seen 0. Okay. Wait, there's one more thing I need to do minus. I need to, if it is current, I know should not include that. So that one I need to like, here is missing. No. Array of ni equal to 0. Then to a 0 count here plus so that I'll not include the current one here, so that will get remaining balance. And yes, I cannot actually do the one here. This is balance 0. One always 0. This looks cleaner. Okay, here was the same thing. One count plus 0 count plus and here min equal to add min of operation required. I think I have written. Let me do a walkthrough before I
Sure.
Take this example. First, one count 0, 0 count 0. I didn't actually reuse any other. Okay. So how many 0 means 0 count will be like limited, 1 count will be there is 1 count. So there will be like total 0, 3, total 1, 2. Now go here. I equal to 0. Current 0 count because I need to. This is a one. I don't want to come on. So currently this is already 0. So 1 is like before is 0. How many zeros after this? 2 zeros. So if I'm making it then 0 count is 3 minus 1. So there'll be 2. 2 operations required. I need 2 operations. So I need to make these 2 into 1, 1. Correct. Similarly, like now over here, minimum required 0. I'll 0. Yeah, I could use this, but okay. Now it's coming here. My 0 count is 1, and my current 0 is also 0. So 0 count is 3 minus 2. 3 minus 2, and 1 count is 0. So I need how many operations? I need 1 operation, and after that it's 1. It's 0. So 0, 1 count is here 0, and the 0 count is 0 count 3 minus 2. Okay, I think this will work.
Yeah, I think this is good. Let's move on because
Okay.
we only have 20 minutes left.
Oh, okay,
So-
great.
Okay, so for the second problem,
Mhm.
you're given a maze, and so 0 means empty, 1 means wall, and 2 means goal.
Okay.
So it's just going to be 0, 1, or 2.
Mhm.
And the border of the maze is always a wall. So like if you think about it, like if you have a 3x3, the whole outside part will be a wall. So let's take an example like this. So I'm just going to draw walls in X to make it easier, but it'll be 1. So an example like this. This is our maze, and the empty space will be like the 0. So we're going to start at some point. So we're going to be given start and goal coordinates.
Okay.
Okay. And we have a ball that starts rolling in whatever direction you want. Right, left, up, down. And every time we hit a wall, we stop and can roll in any direction you want. So you can pick wherever you want to go. So basically the question is, once again, true or false, can we stop at the goal? So wherever the goal square is, we need to like hit a wall and stop there. So let me just give you an example. Let's say we start, I'm just going to say like S is the start or whatever. Let's just say we start at this like leftmost square, and the goal happens to be, or actually, yeah, let's say we start here. So let's do this. The goal happens to be here. So let me write goal. So in this case, we can never stop at the goal because if we go up and down, like we're just gonna hit the top wall and then we can go like left or right or up down, but we can never stop at the goal because we can never, in order to stop at the goal, we have to hit this top or bottom wall. So we're just basically gonna be bouncing back and forth, or anything we hit will be like bouncing up and down, but we can never stop there. So what will let you stop there is if you have the same thing, but the goal is next to a wall and you can actually hit that wall basically. So like in this case, now you would just roll right, you would hit that wall on the right, and then you would stop at the goal.
Okay, got it. Okay. So if only if it is near the wall, it can be true, is it?
So it has to be near the wall, and you actually have to hit that wall. So you have to simplify basically the goal has to be next to a wall, which the ball can hit. So I guess you have to figure this out, but I'm fine giving you like this part.
Okay, okay. It has to be next to a wall, which ball can hit, and the ball can roll in any direction. You means like right, up, and okay. So and it can change the direction. For example, if it's hit a wall, it hit a top wall. Can it actually change the direction to a left and right?
Yes.
So
it doesn't just go like back. Anytime you hit any wall, you can roll any way you want.
uh, okay. I'm maybe I'm not following. Then if that is the case, actually, then all the we could get the whole goal in. Oh wait. Oh, suppose. Um, so, suppose it's a. Let's take an example here. Uh, 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 so I have to hit this X wall, right? If I
Mhm.
hit if I hit this wall and if I'm changing the direction, uh, I won't stop at the goal. I'll go to the
Exactly.
uh,
So this would be a no.
this will be a no. And
Yes.
I can come here and I can. Can't I do this actually? I can come here and I'll hit this wall. Then I can change the direction. I can go here. Then I can
I
change
don't
the direction.
see I don't see like where you're going. I don't see you highlighting stuff. So
Oh, okay, okay, okay. So for example, uh, you are able to see now.
yeah.
If I'm hitting the if I'm starting with the start, I'm
Uh huh.
hitting the I'm going horizontal. And I'm hitting this first X,
Uh huh.
and I'm changing the direction to bottom, and I'm hitting this down X,
Mm-hmm.
and I'm changing the direction again, and I'm
Mm-hmm.
hitting the this X, and I'm changing the direction. Oh, okay,
Yeah, you
because
still can't get to the middle one. Yeah.
I can't get to the middle one. Oh, okay.
Yes.
That's nice. Okay, that's interesting.
Because the only way to hit the middle one is you'd have to be going left or right here,
Yeah, and there
and you
is.
can't make yourself do that.
Oh, good, good. I think, yeah, that's a good. Okay, let me do an again lot of examples to
Mm-hmm.
some more examples to understand. So from it seems like if it is in the uh, I can change this. My goal first. I think I need to like see the goal is near an x, and if it is not, I can simply say it's false.
Mm-hmm.
Uh, but okay, if it is there near a x, and my goal is to hit that x. If I do that, then because I'll be hitting that uh, goal, right?
Yes.
Yeah.
Yeah,
So
because
I'm
anytime you hit a wall, you stop. So if you stop like if you're at the goal and you hit a wall, you stop, then you win. Yeah.
got it. So yeah, if you hit so I'll actually find that x. But for example, if there is a if it is in the corner, there is a two options. I can hit either one. But if it is in the middle border, then actually I have only one option.
Mm-hmm.
And okay, now what are my paths allowed? So generally, it will be like the direction. I'll be going in the one direction, uh, but uh, at the wall I get to choose the. I can actually try it in. I can try. um I try. I can mark this as all visited. Okay, and I can try it in the when I hit the when I hit the corner or the wall. I have two options. I don't know if I'm coming. I have at the corner. I have two options. If whatever the direction I'm coming from, which I will not go anyway. So I have only one option. I have to go down. Uh, okay. Then um, okay. Here DFS will work. My condition is DFS with uh, DFS with some direction uh, unvisited array. Using that, um, I'll go at whenever I hit a car. Whenever I there are
Hello?
options available.
I think my like sound cut out or something.
Okay.
Okay, I'm good now.
Yeah, you're good. Okay.
Yeah.
So what I'm thinking is DFS will work. DFS with a visited array to not visit the path again. What are the
Mm-hmm.
path we visited again? But can and there is also needs to be a direction because I can actually visit this, but if the direction is different, I can actually bounce, right? So that is option, but I feel like there is an opportunity for us to like improve
So
um,
what would be the time and space complexity for DFS with the direction?
with the direction. So what are possible? Um, so if I'm coming to this, the direction will get changed only at the corner, right?
Hmm.
So I have like only the corner two directions, or if I hit this again, I have three directions. Um, so so like three uh, uh, three direction I need to check. So 3 power in the worst case if I have to check all the things, 3 power n.
3
Um,
power n, so 3 to the n, where n's the grid.
three, yeah, three is the n because I need like check in the three different directions, and
Okay, so
mm,
so
mhm,
think about that. So when you use a power, it
mhm.
means it's important to know where you came from because you're like storing the entire path. If I'm
Right.
at a cell like this cell and I
Mhm,
know I'm going down, does it
mhm.
matter how I got here?
I'm going down.
Yeah, like if I'm at some cell and I'm going in some direction, do I need to
Oh, actually,
maintain the path?
actually we don't need, right.
Hmm.
I can actually try it in all the direction, and I don't need to do that.
Yeah, so
Uh,
what would be the time and space complexity?
so then actually in this case it's a simple DFS like out of yeah, like all the cells I need to visit once in post case, order of n.
And do you think you need to store the direction you're going?
I don't I don't need to store the direction. Wait, do you need to store the direction I'm going in? Because if I'm at this place, uh, I need to like wait. Let me see if I'll hit this place and I'll go. Hmm. Yeah, I think I need to. For every place, uh, I have to go down, and I from the start I can roll in any direction, right?
Hmm.
From the start I can roll in any direction. At any place I can at any spot I can go in only the same direction which I came from. Correct?
Yes.
Okay. Okay. Yeah. That is a problem. And when I hit the bottom, then actually I can try all the other directions. Uh,
Yes.
yeah.
Yeah, so
So I
actually
need.
you would need the direction because,
Yeah.
for
It's correct.
example, you
Mhm.
if you swap, you'd get the wrong answer, right? Like here you have
Correct.
to know you're going up or down or you're going to get a
No,
yes and you shouldn't.
true. True. Yeah. Yeah. Correct.
So because you have to store the row and column in the direction, what would be the time and space complexity?
I need to store the row and column and the direction. So so but when I'm coming here, I need to. What I can actually go in the same direction again, right? No, I don't. Do we need to visit again the same cell in the direction?
What do you think?
Uh, so if I hit this cell, I'll be like trying now. I don't need to visit. So I think it's going to be order of n, right? Because I'm going to visit the cell only once, even though the direction might
You'll
change.
visit the cell multiple times because the direction matters, but how many times can you visit it at most?
Oh, okay, okay, yeah. Like for again, I will not visit the same. So 4 times maximum, if in all the directions. If I'm like coming,
Yeah. So
yeah.
basically, yeah. So if you store a row
Mhm.
column and 4 directions, that would be basically like 4 times n. So it
Yeah,
wouldn't be
correct.
exponential.
Yeah.
Okay. Yeah, I think we're
Mhm.
good. You can code. We have
Mhm.
about 8 minutes left or so.
Oh, okay.
Yeah.
Oh, sorry. Oh, I didn't time. Okay. So let me
Or we could
quickly.
also, if you don't want to code, you can make
Mhm.
a super detailed plan to explain what's going to happen. If that, and then we can do that instead. Up to you.
So if it's exponential, I can actually code. I'm like thinking for some optimization.
Okay.
So let's say like DFS, and what I need to return is I need to return it's a true or not,
Mhm.
and current, so the row and column, and the direction I'm coming from, and boolean visited. Do you need visited? Yes. I will not go in the same direction again. Yeah, I might need. Let me think about that later. So if my goal, the current will be the source. If the actually this is not the goal, this is the goal wall, I would say. I don't care about the goal.
Yeah, you can have the input whatever way you want. If you want a goal
Yeah.
wall you need to hit, I don't really care as long as it's the same
Yeah.
thing.
Yeah.
So goal wall is what in this case? Like
The goal wall is the first goal wall is this wall actually. So which the wall?
oh, I see.
Oh, actually, this could be a like a um, list or like something. Can be like, because there could be more than
Yes,
one,
there can be more
more
than one.
more than
Yes.
one actually. So there could be more than ones. So probably I'll have a kind of pair and a set, so that
Okay.
I'll also like do a pair for this, so that I'll create an Java thing later. Let's say because of our position, I'm like the goal wall contains the current pair, return true.
Okay.
Otherwise, I'll check if it is a if it is a you have directions, right? Current row equal to 0, or current column equal to 0, or current what is it, the current row equal to m minus 1, or current column equal to n minus 1. Then in this case, this is a border thing, right? So I can actually have an option to check all the direction, except the current direction. What is it? The current direction. I'll probably should like I'll have a current each direction. I'll have a name for I is not equal to current direction. Then I can actually visit the neighbors I have because of time I'm not DFS. So this neighbor pair will form the new. I have to validate that. Okay, let's do that later. The current direction will be like this direction I, and I don't know whether we visited. I will check, but what else? What else the thing? So at the end, if it is, I tried in. Okay, this is the for the normal. For otherwise, what I'll do is I'll continue within the. If it's not a. If it is not the corner cell, then I can go in the same direction again, right? So DFS new pair. So this is like I can call this and continue the current direction. Oh, do you need visited? I might need visited because I no need to like visit the same direction again, right? No, I'm not going to go in the current direction. If all are exhausted and like if there is no solution, it's false. But here I need to like say it's a valid. Uh, uh, it needs to be like valid row and a valid column. M and N I'll pass so that we can check if it's only valid. I'll try this. Similarly, if it is valid, I'll try this. Directions. Still not figured out that. Got it. What else is there? What else I'm missing? So direction, is it valid? So my only thing I need to like figure out here is the visited with the direction. So if this is visited with the direction, I can I can do this actually. Like I can visited with this direction. What is the direction here? First thing first is like make this true, and this pair can be like a Java object class. So I'm not I'm not going to write that. What other thing I'm missing here?
Yeah, I mean, I think the rest of it is syntax, and you'd have to write like an outer function as well to like make
Yeah,
these things.
correct. Yeah,
That's
yeah.
fine.
I need to. Yeah, I need to
We
like.
can stop here, I think, because we're a little bit over. Okay.
Oh, yeah.
Yeah. So how do you think you did? What do you think you did well? What do you think you can improve in?
I think I'm managing time. I felt I didn't do well. The second problem, it took me like a time to understand. And first problem, I was like focusing on all the edge cases, thinking about, and I think I wasted a lot of time there. Time management. Yeah, I should like focus more. Because of the second problem, I couldn't get a time to like through think through more. Like, yeah.
Yeah, I agree. Yeah, so I gave you like 45 minutes. I think depending on the company for like these are basically like medium questions. So for Meta, you'd get like 40. For Google, maybe you get more. Like I don't know exactly. I think for a lot of companies though, it will be a lot easier where they will just ask you one and then you will like easily do. But some of them there is kind of a time crunch, so it kind of depends. So I think it's good to test people in this like time crunch environment, and then if they can do well in this, then if they get more time, then it's perfectly fine. Yeah. So I would say in the first one, you really tried to have a lot of examples, which is okay, but that is time consuming. So if you write down like 5 examples and you really go in depth, that does take time. So the nice thing is you did really figure out kind of quickly kind of what to do. I think you mentioned like the brute for, like you were like, I need to get the ones or whatever, the ones before zeros after or something. And I could just calculate this and I could use a prefix sum. And then I was like, well, you figure that out kind of quick. So because you're like going for like senior, I was like, okay, can we do a little bit better? And you did figure it all out. I do agree. You did kind of have these like, how do I calculate this? How do I calculate this? Am I doing it right? Am I doing it wrong? Like, I don't know. So what it would have been good is for you is to have a little bit of like exactly what you need to do. And you did figure it out in the end, but it just took a lot. It just took quite a bit of time, right? So I would say something like pre-calc zeros and ones, and then like calculate left and right on the fly, left and right on the fly, and then actually have an equation here, right? So like, what do you need? You need like ones on the left, right? Ones on the left. I have, and then zeros on the right is total zeros minus zeros I've seen. And then, yeah, you could have actually done this like, I mean, depends how you want to write it. You could decrement the zero at the current thing before you do this, and then that's basically it. And then now that you have that, you can be like, oh, yeah, this is good. And then I can refer it and I can do this. Because I think that's the thing that slowed you down a lot is you were like trying to not have these off by one errors, and it took a while for you to be like super confident in your answer.
Got it. Yeah. That's correct. I wanted to be super confident. I already I know that actually we could do even I should have went for coding even before. Last last time like I did a mistake in coding before, so I don't want to like do that.
Yeah, no,
I,
absolutely, yeah. So what I would say is if you have some tricky calculation, try it before the code, verify that it works, and then have the exact calculation like written down in your, and then you just copy it into your code, and then that would have been fine. But yeah, I mean the code was fine, and yeah, basically you could have written a few different ways, but you did basically come up with like the optimal solution. But the main thing, so I gave you like a solid higher for everything other than the speed. The speed you kind of went over, and then the second problem you had to rush like crazy because you went over on the first one.
True.
So definitely try to figure out places where you can save time, which is like you probably don't need. At least you didn't go in the wrong direction. A lot of people try to get a lot of examples, and then they're like, okay, how can I get like a solution that handles all of these examples, and then it like doesn't really work. Like you have to just check at every index, but a lot of people go into the like, let me try every example and find some generic thing that like works all the time, and it doesn't. And then I have to hint to them that like this doesn't work, you should go in another direction. But so I think your problem solving was good. I think your coding was good. I think it's mostly just the speed. Like take what you know and do it faster.
Totally.
Which is like a good problem to have, right? Because a lot of people like can't solve or can't code or whatever. I think you're good at both. You just have to be more confident and do it faster and like correctly. So literally just take what you know, practice a little bit more, do it a little bit faster. And then second one, same kind of thing. I feel like it did take you a while to understand the problem. To be fair, it is kind of complicated. And I was like, I have these two problems. I don't know how long it's going to take you to do the first one. So I could have been like, well, it took you a while to do the first one. Maybe let's pick a second one that like is shorter. I could have done that, but I was like, I just have these two, so I'll just give you these two no matter how well you do on the first one. Because yeah, like I'm not, I don't want to change it. So, and I think that's what most people will do. They're not going to be like, oh, you took a long time on the first one. Let me give you like two sum or something so you could finish,
Oh, got it. Yeah, thank you for that. Thank you for not doing that.
Yeah. So I feel like I did that sometimes in the past where I'd give them like an easier, faster thing, and I'd be like, well, yeah, you did this easier and faster thing, but it's because I made it easier for you. So, okay.
But it is just challenging, like to do it in the short time. I got a good experience out of it.
Yeah. So the one thing you did that was quite bad actually here is I never said that you can't have walls in the middle. And you basically don't handle that at all.
Oh, true.
So I would have clarified that because I was like, okay, I get your solution. You're checking if you hit a border, and if you hit a border, you hit a wall. But I was like, but you can just have like a wall here, or whatever.
Oh yeah, I didn't due to shut off time. I didn't properly clarify the.
Yeah, and so it's kind of like a snowball effect where you're like running out of time on the first one. Now you skip a lot on the second one, and then it kind of like gets worse because you like skipped a lot. Like so if you had plenty of time, you could have definitely asked like, oh, can there be walls? Can there be this? Can there be this? Whatever. Maybe I could have given an example with that, but I also did say we have a matrix of like empty walls and a goal. and then I just drew that example. And I think it's also good to, in my experience, it's good for me to have these like really generic examples that don't give you like all the edge cases, and then you have to go and like point it out yourself. I think it teaches people like when they get burned by not asking stuff. Then in the actual interview, they're like, "Oh yeah, maybe I should ask everything because like last time I did this, I forgot, and then my solution didn't work." Um, so I think it's a good experience for people if I just like am super vague on purpose, and then they screw up, and then I could point it out to them, and then I feel like it sticks better. Uh,
Thanks for that. This is a really good.
yeah.
I think I'll
So
remember this for my
yeah,
life.
I feel like that's the way people remember the best is they like get burned, and then like yeah. So the other thing that was not good for the second one
Mhm.
was yeah. So you basically said like I need to have this direction and I need to have the row and the column, and then you said this would be like 4 to the n or something, which
Mhm.
is only true if you do like a backtracking solution where you're storing the path. Because if you
Mhm.
think about it, if you do like DP, right, and your memoy
Mhm.
state is like row column I, this is not 4 to the n. This is just row column times I. So definitely like brush up on your time complexity, and if you're like off
Mhm.
significantly, like if you just say the wrong like completely thing, then that's not good either. Um,
Oh, got it. Okay, got it,
yeah.
got it.
So
Yeah.
basically, I was trying to hint at like when we're at a cell, it doesn't matter how we got here. Like if we're at
Mhm.
some cell and we're going in some direction, we don't need the path to get here. We just need to know where we're at. So then the most states are going to have is what is it? 4 times row times column. That would be linear. So I had to like hint you a bit
Yes,
there.
actually, I was confused at that moment. Uh, I was not clear on the algorithm side.
Uh
Uh,
huh.
I was I had both the option in the mind when you
Uh
asked
huh.
the question, but I was too focused on the algorithm,
Uh
and
huh.
I had a 4 into n and a like 4 power n. I have both the solution, but I
Got it.
was like, yeah,
Yeah. Yeah. Yeah.
thanks
So,
for that. Yeah.
yeah. So I think DFS, BFS, fine. Whatever you're comfortable with, it's
Mhm.
fine. I think your let's see. Your code was pretty good. I mean, you kind of have to rush it, so you skipped a lot of stuff. But
Mhm.
yeah, I feel like if you had time, I
Mhm.
feel like you easily code it. You easily know like how to write like this kind of stuff. You basically just same thing for the second one, right? Like if you had more time, I think you would have done pretty well. You would have got the right solution. You came up with the right algorithm. Yes, there was like the time complexity thing. There was like the clarifying questions, but that's all solvable. It's not like some big thing. So definitely just make sure you ask like all the right clarifying questions and figure out a way to go as fast as you can. I mean, obviously it's company dependent. Figure out like how many
Mhm.
questions, how much time, and then you can go off there. If it's like one question 45 minutes, you can definitely like slow down. But a lot of times when that happens, the one question will have like follow-ups and stuff. So if you take too long, like they'll have follow-ups, and then sometimes that you won't even know that there's like follow-ups because it's like, well, we did like one part and there's like 5 minutes left and I have a follow up, but I don't want to ask you because this thing will take like 20 minutes. So I'll just say, let's end the interview. And then you think you did everything, but you didn't. Um, so that is also the case. So ideally, you want to finish like as fast as you can while also having a good solution. Um, yeah, while basically having a good solution and uh, and having a working solution. So I think it's good practice to work on speed. I think speed is one of the more common. There's basically 3 areas I think people struggle in that I can kind of like break it down into is problem solving, like going from the problem to a solution. I think you're pretty good at that. It's just a little slow. Coding, going from a problem to like good code. I think your code's pretty good and pretty clean and pretty accurate. And then speed. So I think you just have the last one, which is the speed. So basically, just like make sure you practice, make sure you can like do problems, make sure you can do things faster, and like I think everything else you're doing is fine. So for this one, I basically said like for the first problem, this would be like a solid higher, and for the second one, because you didn't finish, I would say like lean no higher. So maybe like in between, it would be like a lean higher or something. But I usually tell people that like if you get a lean higher, you basically have to have other strong rounds because typically in this market, if you get lean higher, people do better than you, so you usually don't get hired.
True.
So
Yeah,
yeah.
that is a tough market out.
Yeah, so I would try to like it's possible you get the role, it's possible you get down leveled or whatever, but I think it's a good idea to try to aim for like a strong bar instead of like the barely getting hired and like hoping you get lucky. Um, so yeah, basically I would say just work on the speed, and I think everything else is pretty good.
Thank you
And
so
then yeah,
much.
do you have any questions?
No, this is wonderful feedback. Thank you so much. I
Okay.
got a real world experience.
Okay, and I have one quick follow up for you. So, what do you think about like the questions I asked for like this tile of interview? Do you think it was like not enough time? The questions were too hard, or was it like all good?
No. I think the questions were like both questions. It seems I like you said actually if I have like properly managed my time and I should be able to solve and both are like I feel like it's a medium level complexity. Uh,
Yeah,
with
especially for Google. Like Google is pretty tough. So yeah.
yeah, the second question is, it was a little harder for me to understand visualize,
Mhm.
but it's mainly because me I didn't properly time on the first question.
Yeah, definitely that can snowball.
Mm.
Yeah, for sure. So definitely, like if you finish the first one in 15 minutes and you had 30 for the second one, then you can like take your time, and that's the ideal spot. That's the ideal spot to be in. So yeah.
Thank you for that. This is like both questions are like wonderful questions to judge on multiple areas.
Okay. Yeah. I tried not to ask stuff that's super common so people can just regurgitate a solution because it becomes kind of bad. So yeah.
True. I have like I when you were writing, I thought actually I might have seen already, but both the questions I have not seen in the seen before. The
Yeah. Okay. All right. Cool. So yeah. So if you want to sign up in the future, feel free. I just tell people don't sign up in like a month duration because I'm pretty much booked forever. So yeah, if you want to sign up in a month or two, you can feel free when the slot opens up.
Thank you. Yeah.
Okay. Cool. See ya.